Okay, so area between curves. Okay, I'm going to go back to basic skills that you've had regarding area, and I'm going to use some different colors here. So let's say I've got this rectangle, and I tell you that the area of this red rectangle is 20 square, whatever our units are. So let's just say the area is 20. And then I come in and I say, well, I'm going to put another rectangle. And its area is, let's say, 14. Really, this part's not important for your notes. It's just getting you to think about what we're about to do. But let's say I want to know what this area is that I've done in black. And you're already doing it, right? You know what the answer is, don't you? It's 6. You're going, well, if this whole red part is 20, this part down here is 14. The part that's not covered up, I just did a simple subtraction, right? I mean, and you do that automatically because it's very simple. It goes back to something you did like in elementary. So what you're telling me that you did is you took the top area, right? And you subtracted the bottom area. Isn't that what you did? So as you go through and we start talking about area between curves, I want you to realize all you have to do is look at the top curve and subtract the bottom curve. So always go back to like these simple ideas. There's no guess in which order do I have to do this. You're going to think about this in terms of the top curve minus the bottom curve, and we'll write that down. So the area between curves we have to make it a bit more mathy than that, right? So the area between curves, I have a comma. I'll say if F and G are continuous, let me put with the function f of x greater than or equal to g of x on an interval, let's call it from a to b, then the area between the curves f and g from where x equals a to x equals b is the following. And it's what we just said. We would take the top curve, and in this case we're saying that f is greater, so that's the top curve. So I would write this as the integral of the function f of x minus g of x, integrating with respect to x, and what are my bounds? A to b. Okay. So you can put here, this is going to always be the top curve minus the bottom curve. Okay, so if you think back to the problem we had with our quadratic, and we were looking at this region, we could call it region A, and we said what you actually have here, it's a curve. We told it was y equals 0, and what was the function? We said it was like x squared minus 4, right? Okay. Could you actually find region A by doing this area between curves method? How would you set that up? What's the top curve for that portion? It's 0. So if you look at that, and we had some bounds here. We said this was 0 and this was 2, wasn't it? We said from 0 to 2, I could take the top function. Well, the top function in this case is y equals 0, so I put down 0. And then I would subtract the bottom function, in this case, which is x squared minus 4. So if you work this out, your integrand, when I work it and I actually plug in my endpoints with fundamental theorem of calculus, I'm going to get a positive answer, whereas before we had to apply an absolute value, didn't we? Okay, but if I think of it as area between two curves, I'm not going to have to worry about taking the absolute value. So it really just goes back. This is top minus bottom. So now it makes sense as we're in this next section. So any questions on that? We could have done it a different way. We just didn't know about it yet. Okay, so help me out a little bit. And perhaps maybe we'll put this in your notes first. So I say help me out, but let's put this in our notes before I go too far. Okay, this is our function f of x. Draw something similar to this on your paper. And go ahead and put the x value of a and x value of b, similar to what I have here. Okay, you can shade it in. And we'll go through a couple stages of this just to make sure you understand it. If I were to ask you to find the area, you would write what right now? This red area, how would you find it? You could do from A to B, right, of f of x. I'm in the first quadrant, but if I'm thinking about two curves, I could subtract nothing, right? Because this is the line y equals 0. So I don't really have to show that part. Okay, let's add on to this. This way it goes in your notes, so if you look back at it later, like, oh yeah, that's what I did. Okay, so we've added another graph. I say write the definite integral that gives us that blue area. You're just going to write what? So just the blue part, right? Yeah, so just g of x. The bottom curve is really 0. I don't necessarily have to put that in there, but it's okay for my notes. Okay, so what do you think the last thing I'm going to ask you to do is? Let's draw another picture so it's in our notes. We look at this. You'd be surprised in like 10 years, you'll go, man, I used to know how to do that stuff. So keep your notes. Show your children, look, this is the stuff I used to do. And I'm trying to get it to select, so hang on. You guys go ahead and start drawing this graph. I'm going to try to make mine look consistent, so I'm doing a copy-paste here. So now I'm going to find the area between curves. This is for my notes, so it makes sense. Do a green. And I know you had this before, but this is so when you look back at it at 2 a.m., And you've already probably gotten this written down. What am I going to write for the green? Yep, f of x minus g of x. Okay, so we're all on the same page. Top curve minus bottom. Okay, and this should absolutely make sense to just that basic example we did with a simple rectangle that you probably give like a third grader, and they're like, oh, I get it. But now we're going to apply it to functions. So these will get trickier as we go through. So we're going to start off with some basic things. Your calculator can help you some. On some of it, you're going to have to know how to use your calculator. So if you have not been using your calculator to graph, you may want to get a little bit better at finding your window and things like that. These aren't always going to be easy to see. So the first problem is going to be to find the area bound by y equals x squared minus 2. And I always like quadratics because those are so quick to graph, a quick sketch of. And then we have the line y equals x minus 5. And this time it's going to tell me I'm going to look between where x is -3, and I should use the word 2, x equals 2. Okay, so I'm finding area between curves. And I know I'm supposed to think top curve minus bottom curve. Do I know offhand which is the top curve? Can I just start plugging stuff in and going with it? Not a good idea. What you need to do each time is actually to draw it. Okay, you need to draw it or graph it. I'm going to expect you to at least have a sketch. I'll provide you some graph paper. So we actually need to graph this because we need to determine which is the top curve. Okay, so what points for that quadratic can we go ahead and put on there on the graph? Okay, so the vertex, can everyone tell this was x squared, and that starts at 0, 0, but it's been shifted down 2 units? Good. So I've got my 0, -2. Do I know some x-intercepts? It's going to be plus or minus √2, is that correct? Okay, what's plus or minus √2 close to? It's 1 point something, isn't it? Okay. Okay, so it crosses somewhere over here, right? Can I get a good general shape of this? We know what that looks like. Okay, we'll see if this is good enough to figure out the top curve minus bottom. Okay, can I graph easily the y equals x minus 5? Hopefully. What am I going to plot first? Yeah, you go down to your y-intercept, which is -5, right? Okay, and then how do I plot my next point? Look at the slope. Okay, and the slope is +1, so I'm going to go up 1 and over 1, right? Okay, and then I have enough points to make a pretty good graph. Okay, is it pretty clear what our top curve is? Let's see my... Okay, and it says we're going from -3 to what value? 2. So I could extend this if I want, but I really don't have to see the full thing. But it says I'm going from where x is -3 all the way to where x is +2. So we're looking at this region. Does that look okay? Did I do anything weird? Okay, so I had to draw it so that I would know what the top curve is. It's very clear now what that top curve looks like. And so tell me how I start writing this integral. Excuse me. So I've got my bounds. It tells me exactly where I'm looking. The area is from negative x equals negative 3 to x equals 2. Yep, the top function is x squared minus 2. Good. Minus the other function. So do I have this right?
Yeah.
Okay, so I could do exactly what you're saying, which is to switch the sign, which I'll probably do in the second step. But do you realize I'm subtracting a whole function here, right? And so I can go ahead and account for that and flip the signs as long as you don't miss that. But I'm going to go ahead and show this for notes. Okay, so I like what you said. Let's go ahead and distribute. So I'm going to have x squared, and then I'm going to go ahead and write this in descending order. So I would write this as x squared minus x, and then I would have a plus 5 and a minus 2. So it's going to be a plus 3. You guys agree with that? I'm just combining the like terms and writing it in descending order. So I distributed. Is that okay? All right. Okay, I'm going to pause for a moment, and I'm going to let you find that. So we come down to plugging in our endpoints. So we would plug in, according to the fundamental theorem of calculus, we would plug in the positive 2 into our antiderivative, and then we would subtract. And notice I have that set of parentheses in red. I'm subtracting the function value of the antiderivative when I plug in negative 3. So that means I'm going to subtract whatever I get here. So I showed a lot more than was necessary. You get your calculator out. You make sure that you go through each one of these things. Don't miss your parentheses on your calculator, for example, with the negative 3 being cubed, or if there had been a square or something. Just really watch how you're typing those things in. But you come down to it, and you should end up with 175 over 6. Okay? And so if you missed it, it's not likely that you missed the calculus portion. It's likely that you missed the arithmetic. So it's just being very careful whether you're doing it all out by hand or if you're using your calculator. So do you guys have any questions? Comfortable with this one? Can I give you one to work on your own? Okay, I want you, if possible, to start on this next one and try it. So let me go ahead and write it down. The area is going to be found between the curves y equals, that looks goofy, y equals 6 minus x squared, and y equals x. So you're going to find the area between these two curves. That's all that's given. Seems weird because what additional information did it give you last time?
X equals negative 3 x.
Gave you some bounds. You need to graph this and see why I don't have to give you those. Okay, so you need to try this one. So graph them. Graph them and see what they look like, and you'll notice I don't have to give you any more information than this. Okay, the first thing you had to do, I gave you as much information as I needed to do, because if you graph these, you know you're looking to see what's the top curve and what's the bottom. The way I think you should probably approach this, aside from just punching this into your calculator, is think about the algebra behind it. So maybe you had college algebra, or maybe it was just algebra 2 in high school, whatever it was. You have a basic understanding of what a quadratic should look like, and the fact that this is written as 6 minus x squared shouldn't bother you. It's the same thing as negative x squared plus 6. And you go, oh, if the leading coefficient on a quadratic is negative, well, I know it's going to be an upside down parabola. It was reflected across the x-axis, and this plus 6 tells me that the vertex was shifted up. So I can verify that on my calculator, but that allows me to do a nice, easy, simple sketch. The next thing that you want to do when you sketch these quadratics is you want to find those x-intercepts. And so can you tell me what your x-intercepts were?
Negative 3 and 2. Wait.
2 points.
So, and be careful about this, because I shouldn't have an exact number, should I? Because it's the square root of 6. So it's good enough for me on my graph to say square root of 6 is between 2 and 3, right? Because 2 squared is 4, 3 squared is 9. So it's between 2 and 3, a little bit closer to 3. So you can see like my graphs are obviously not perfect. I don't have graph paper, but I have something good enough to show me where I'm crossing the x-axis. And then the next thing I do is graph this linear equation. It starts at the origin as its y-intercept. I go up 1 over 1, and this allows me to draw the region that I'm looking at, which I happen to shade here in yellow. And so I know, based off of this graph, without going through the bounds yet, I know that I can say the top curve is what? The quadratic, right? And you could put that in whichever order you like, right? All I did is reorder it. So I have my top curve, and I'll actually just put a parentheses for no reason, but, and then minus my bottom curve, which is x. Okay, so this seems good. Now, what are my bounds? This is where it gets tricky. It's where the curves intersect. So if I chose to do just like the negative square root of 6 as my x bound, and over here the positive square root of 6 is because those were my intercepts, I am either losing or gaining area that I don't actually have. I want all of the area between curves. And so you're absolutely correct in saying I need to find out what the x value is when these intersect. How do I do that? You set the two curves equal to each other. Where they are equal is their intersection, right? They're going to have the same exact x and y value. So that's what you can do. Now, could you use your calculator and use intersect on your calculator? Yeah, but do I really want you to do that? No, right? I want you to show me everything. So I'm going to set these curves equal to each other. And so that means I'm going to take the curve x, and I'm going to set it equal to the curve negative x squared plus 6. And then this is probably where a few moments ago someone was answering, I'm going to solve for that x value. I'm going to use a quadratic method, so I'm going to put this into standard form. So I'm going to move everything from the right-hand side to the left. So I'm going to have x squared. I'm going to put in descending order. So I'm going to have x squared plus 6, or excuse me, plus x minus 6 equals 0. And then I'm going to see if I can factor this and find those x values. And then I'll probably use my calculator to verify if this was correct. Okay, if I factor this, can I do that? What is it? X. All right, good. And so you have x is negative 3 and x is 2. Okay, could you go to your calculator and check it? Yeah. Okay, so this is actually what I need. Do I need the y value where they intersect? No, because it says I'm finding the antiderivative with respect to x, so my bounds are in terms of x. So if you got this far, that's great. Okay. The next part of it is just taking the antiderivative. And there's nothing tricky about the antiderivative of this. I don't have to go through and do any algebraic simplifying other than some basic things. And I don't have to use substitution. So I will maybe just rewrite this for a second. What's the antiderivative? Negative 1/3 x cubed minus 1/2 x squared, yep, oops, plus 6x. And then he showed me that you're going to evaluate it from negative 3 to 2. Okay. And so for the sake of my notes, I hope you already have this in yours. I'm plugging in my bounds. I'm subtracting whatever I get when I plug in the negative 3. I go through very carefully, and what do we end up with? What is it? 125 over 6? Okay. I have that in my notes. Okay. We're going to find the area between y equals x squared minus x and y equals 2x. And you'll see in a moment when you graph these that you're going to take it from, you have to have bounds, so it's going to be from where x is equal to negative 2 to where x is equal to 3. So actually, how about we regroup as soon as you have these graphed? And then I want you to talk me through and tell me what you think we should do. So you've got this region, right? Okay. And I know that there's going to be something in here, but do I have anything up here? That was the question I got. How will I know? You got to figure out what this bound is. That's right. So this could be 3 or 3 could be over here, right? I have to be really careful. Can y'all see when I put, nope, you can't see my pen. So right here, this could be like 3 could be over here. I have to check. So I need to figure out what is that intersection. So I need to make sure, is there an additional spot I have to, is 3 possibly, could this be 3? And do I have part over here? I have to verify. I'm either going to have to be really good with my calculator or I have to know my algebra. Okay, so let's figure that out. How do I find out where they intersect again? You set them equal to each other, and you're talking about the x squared minus x set equal to 2x, is that correct? Yeah. Okay, they're obviously intersecting twice here. We're going to be able to tell real quickly by our solution where we are. So I've put it in standard form. I've taken 2x, moved it to the left-hand side. Help me out. Can I factor this? What is it? What is it? Can I? So I'm looking for two numbers that multiply to -1, but add to -2. You can combine. That's absolutely right. Okay. So I've got x squared. I mean, you have to think about the elementary things. So I've got x squared minus 3x equals 0. So it really wasn't even hard. Remember our like terms. This is simple factoring. What do you get as your two numbers? And? Okay. So what does this look like it actually is? 3. Does that cover everything I want? Do I have to go over here? No. Okay. So when I am actually setting up my area, I can call it region A for the sake of communication and region B. What's area A going to look like, the definite integral? Okay, so you've got your bounds. I heard from someone. It's going from -2 to 0. What's your top curve? It's that quadratic, isn't it? So x squared minus x, and your bottom curve is 2x. Okay, I don't need a set of parentheses on that, right? Because it's just a single term. I'm going to have to add area of region B. Now what? 0 to 3, right, from here to here. And what's your top curve this time? The top curve is the line, which is 2x. The bottom curve is the quantity, x squared minus x. Can I just put these things together in one single integral? Is the function order the same? Is it the same integrand? No. So remember that property we did last time, we said that we could break this up, but that had to have the same integrand. So you actually have to perform two separate applications of the fundamental theorem of calculus. Okay. After you find your antiderivative, you're going to use the fundamental theorem of calculus to evaluate both of the antiderivatives using the far endpoint minus the near endpoint. And your final answer should come out to be 79/6. And you don't have to show all this work, you can use your calculator.